Since 1928, we've had a blast furnace blowing engine here at Port Kembla, an engine that started work earlier in Lithgow. You could call it an old friend. For 40 years it's been working, from the flywheel 16 feet in diameter, weighing 26 tons, to the intricate tiny movements of the automatic lubricating gear. Some of the men who helped install the engine are still here at Port Kembla. Harry Solomon is one of them. Herman Fisher is another. He came from Switzerland in 1928, and he's still keeping a friendly eye on the old engine. The engine is controlled by an electric motor working with the governor. The engine's full name is Cross-Compound Blast Furnace Blowing Engine, and it's even bigger than its name, 56 feet by 25, 330 tons on foundations of more than 1,400 tons of concrete. The high-pressure steam cylinder is 3 feet in diameter. The low-pressure steam cylinder, 5.5 feet. Air cylinders, both 7 feet, with a common stroke of 4 feet. Steam pressure, 225 pounds per square inch. Air pressure, 30 pounds. At 100 revolutions, the engine displaces 60,000 cubic feet of air per minute. The engine went into service in Lithgow in 1923, and in 1928, we moved it to Port Kembla. It's been on the job since, blowing air to the blast furnaces. When the big blower started here, number 1 blast furnace was our only furnace. The first year's production was 4,400 odd tons of steel. At the time, it was pretty good, but it looks small against last year's total of more than 3 million tons. At number 1 furnace is a director of Thompsons who was with them when the blower was built, to wit, John Ogilvy. With him is myself, the general manager at Port Kembla. The blast furnace is ready for tapping. To make steel, you need pig iron. To make pig iron, you need air. So the big blower has done its job in the development of the steel industry, and that's an important part of Australia's development. Our 1928 setup has grown until now we have 2 open house shops producing steel and 4 blast furnaces to supply the pig iron to them. Near number 4 blast furnace, iron ore is unloading. Iron ore to make steel, steel to make, well, the ore bridge, the ship. Steel is everywhere. Steel makes our bridges. Steel is cast and pressed for cars. There is steel in the rigid skeletons of our buildings. Steel trains run on steel rails. Steel in the little things we use without really noticing them. And of course, steel in the big blower. The engine is the biggest of its type made in Australia and the biggest ever likely to be made. Building it was a test of all the skills of the men working on it. The crankshaft was forged from a single steel ingot. With cranks and eccentrics, it weighs 27 tons. The piston rods are 1 foot in diameter, but for all its size, the engine is built to the highest standards of finish and accuracy. To build it today would be all but impossible. Industrial skills have changed. You'd have trouble finding a team to produce the huge forgings and castings that were made in 1923. Even 40 years ago, the company had a long and successful history, going back almost another half-century. When the engine was built, management was in the hands of William Valdemar Dam, one of the first engineers in Australia to introduce micrometers and gauges for fine working, and of S.D. Rex Thompson. In the drawing office, draftsmen were ready to tackle the problems of the blowing engine. They had designed equipment for mining, railways, shipping, and irrigation. The foremen had the same experience. They were specialists in their trades. Fashions in clothes and moustaches have changed since then, and skills have changed, but standards remain the same. There was a staff of 550 men to carry out the work. It might be the biggest blowing engine ever built in Australia, but they were confident they could build it. The workshops had the equipment, some of it designed and built by the company. More riveters than welders, more blacksmiths than electricians. But they knew their jobs, whether they built rail points and crossings, mining pumps and winders, air compressors and generating gear, or the big blowing engine that's been doing a job for 40 years. Steam power in the reciprocating engine we will see less and less. It is being replaced by newer ways of using steam. On April the 19th, 1963, we brought the engine to a stop. The big blower had done its job. The engine is stopped for good. The giant spanners from the shadow board are used for the last time to start the work of breaking up. In 1923, the company had the men with the skills to build the big blower. Today, they have the men to build today's equipment of many types to match the record of the 40 years big blow.